Were you surprised that some of the fruits that you tested sank even though they were smaller, and some of the bigger fruits floated even though they were bigger? Well, if objects float or sink, actually doesn't matter how big they are, it matters how dense they are. That means when we cut open this orange and we look inside, we'll see that the matter is actually more spread out. That means it's less dense. And today, you're going to learn that less dense things float, and more dense things, things that are tight together, they sink. So density is exactly that. It's the amount of matter in a certain space. We're going to write that down. Density is the amount of mass, which we know is matter, in a certain volume or space. So, like I just mentioned, if it's less dense, it's going to float, and as we get more dense, we sink. So less dense, like this orange, floats, and as those molecules get closer and closer together, we say that that's more dense, closer packed, and that's going to sink. You're going to make two observations, and using your notes, what you know about density, less dense things float and more dense things sink, you're going to make an inference. But first, you need to know that the density of water is 1 gram per milliliter. That means 1 gram of matter or mass per every milliliter of volume. Mass per volume. Let's take a look at our observation. What I want you guys to write is your glasses, OBS 1. You're going to draw a cup of water before and then a cup of water after. In this picture, you're going to leave. In this picture, when I drop the egg in, I want you to draw what the egg did. So you're going to add your egg to this picture. So in the second picture, you're going to draw what happens when I add this egg. Go ahead and draw your observation. What happens to the egg? Does it float or sink? Okay, let's make a second observation. So go ahead in your notebook. Go ahead and write observation 2. I'm going to add some salt to the water. So you're going to do the salt water. But then your observation, the after, is going to be what the egg does in the salt water. So I'm going to take my salt. I'm going to take my egg out of the water. I'm dripping on my paper, sorry. And I'm going to add more matter to the same volume. Because all of these salt molecules, which we know are sodium element and chloride element, is going to add more matter, more stuff inside the same space. So if I'm adding more stuff, I know my molecules are getting more close together. Let's add a few more. All right, and now I'm going to mix it. This is a physical change because even though the water and salt is mixing, it's still water, it's still salt. Dissolving is a physical property. Solubility, physical, because it's still the same matter. All right, these now have more molecules in it, and the egg didn't change. So again, in your notebook, in your second picture, you're going to write down what happens. A little bit different. Go ahead and write down, did the egg float or sink? And after we make our observations, we need to finish with an inference. So the last thing I want you to do, where it says inference, so go ahead under your two observations, write I and F, and draw your brain, waffle brain, and you're gonna write down what the egg did in the first observation with regular water, what the egg did when we added salt, and why you think it changed. Okay, here's the real reason. Let's see if you got it. The egg floats in the salt water because it must be less dense. We added so many more molecules here that our egg was actually less dense. So let's draw a picture of that. In regular water, the egg has more molecules per space, so it's going to sink. But once we add salt to the water, the water has more molecules, it's more dense, and the egg becomes less dense. So the egg floats. Again, less dense things, like this egg, float. But if the egg's more dense than the water, like in regular water, those things sink. Hope you enjoyed learning about density. We're gonna figure out how to calculate it tomorrow.